chapter, chapters 8 and 9, which are the trig chapters, what we're going to be looking at is we're going to be looking at angles in standard position expressed in degrees and radians, developing the equation of the unit circle, solving problems using trig ratios, and then graph and analyze the sine, the cosine, and the tangent functions. So some of this stuff is review, some of this stuff is going to be new. So in this section, we're going to look at angle measurements. So we're going to look at degrees. So angles can be measured in degrees, where 360 degrees represents one complete rotation. So when I'm creating an angle, I have this initial arm, this starting point. And this starting point actually matches up to a coordinate axis. So that initial arm is on the positive x-axis. And then where we stop the angle, we call that the terminal arm. Terminal meaning stop. And then we have this angle that is created, and then the point that's created with the two lines is called the vertex. And most commonly, the vertex is on the origin. The angle that is shown in the diagram is said to be standard position. What it means to be in standard position is I've started on the positive x-axis, and then I've rotated counterclockwise. And we rotate counterclockwise because when we number the quadrants, we start 1, 2, 3, 4. Another way to remember it, if the sun rises, it rises in the east. So if I think of this as being a compass, this is east, sets in the west, goes around the planet, and comes back up in the east. Okay? On the coordinate grid, a positive angle is when I go in a counterclockwise rotation. So this diagram right here would show me a 235-degree angle. If I decided that I want to be different and I want to go clockwise because I like clockwise, that's the way my watch goes, my angle is negative. So this angle measurement right here would be negative 247 degrees. Something else to consider, each quadrant is 90 degrees, so I count in multiples of 90. So I get 90, 180, this is 270, so 235 is somewhere in between. And then if I'm going backwards, negative 90, negative 180, negative 270. So negative 147 is somewhere in between these two amounts. Okay? So let's look at the first set of class examples. It says, sketch the rotation angle in standard position and state the quadrant in which the angle terminates. So 290 degrees would put me in what quadrant? 4. Pardon? 4. Quadrant 4. And I'm not looking for it to be exact. I'm not going to take out a compass and make sure it's exactly 290 degrees. However, this line should be drawn closer to the 270 than the 360. So some measure of accuracy, but I'm not looking for precise. And then I would label it 290 degrees. And then I show the arrow. So now in the second one, if I'm going negative 135 degrees, which way am I rotating? Clockwise or counter? Clockwise. So in clockwise, this becomes a negative 90, and then this becomes a negative 180. So negative 135 degrees would be somewhere in between, and it's actually halfway in between. And then I would draw an arrow just so that I know which way I'm rotating. That's the purpose for the arrow, is it tells which way I'm doing my rotation. And then I label it negative 135 degrees. The degree symbol is important because in this chapter we start using angle measurements other than degrees. We start measuring in radians. So we do need to differentiate between the two. That's what the degree symbol is for. What can you tell me about a 750-degree angle? It's going to go around. The first time is 360 degrees. The second time gives me how many? 720. So 2 times 360 gives me 720 degrees. And then I need to go another, how many degrees after that? 30. So a little bit more. And there's my drawing. But what's important is that I show that I've gone around twice and then up a little bit more. So I'm in quadrant 1, quadrant 3, quadrant 4. And then again, I can also label this 720 degrees. Okay? The point A lies on the terminal arm of an angle of the rotation angle theta. In each case, draw the angle theta in standard position. So if we start off with our coordinate axis, our xy. Where would I find the point A? What quadrant?
2.
Quadrant 2. So 3 to the left and 4 up. There's point A. So I'm going to draw a line from the vertex, or from the origin, through point A. And then my angle in standard position starts from the starts from the initial arm on the x-axis and goes to the terminal. That's my angle theta. Okay, so I'll give you a moment and I want you to do the second one. So what quadrant is point P in?
3.
Quadrant 3, so 7 to the left and 2 down. So I draw a line through P, and because it's in standard position, it's going to start at the positive x and go to P. That becomes my angle theta. Okay, how are we doing so far? Okay, so now we introduce a new term called coterminal angles. So if I drew an angle that was at 150 degrees, which quadrant would I be in? The second quadrant, and I would be close to 180. If I wanted to draw an angle that was negative 210 degrees, so negative means I go in which direction? Clockwise. So here's my negative 90, negative 180. So negative 210 is again going to put me a little bit over into quadrant 2. And then 510 degrees. What do I know about 510 degrees?
You'd have to go around more than once.
To go around more than once. So if I take off 360, what am I left with? 150 degrees. So I go around once, and then another 90, and then I'm not quite at 180 again. And there's my 510 degrees. What do you notice about all three angles?
They're the same.
They're the same angle. They line up. If I was to put them all together, their terminal arm would be at the same point, which is why they get the term coterminal, because they stop at the same point. Okay? Within the coterminal arms, there is a principal angle. The principal angle is the positive angle between 0 and 360 degrees. So this one would be my principal angle, because it's the angle I get in the first rotation. 510 degrees, I've gone more than one rotation. negative 210 degrees, I've actually gone clockwise. I need to be going in a counterclockwise positive rotation. So in the diagrams, the principal angle is the one that is 150 degrees. Now, I can keep drawing coterminal angles. I could draw another coterminal angle where I just wrap around until I get to 210 degrees. That one would end up being negative 570 degrees. I could make another coterminal angle of 870 degrees. I could make another one that would be 1,130 degrees. How am I getting these numbers?
Just add 360.
I'm adding multiples of 360. So there are infinitely many angles that can be coterminal with a given angle, and they can be found by adding or subtracting multiples of 360 degrees. So I take my principal angle, which was 150, and then I can add multiples of 360 degrees. And I let n be an integer. That's my disclaimer. So if n is equal to 0, I'm at the principal angle. If n is equal to negative 1, I'm at the negative 210 degrees, and so on. Okay? So in class example number 3, it says, in each case, determine the angles in the domain from negative 360 degrees to positive 360 degrees, which are coterminal with the given angle, and then write an expression involving the principal angle that could be used to represent all angles in the domain that are coterminal with the given angle. So I'll do the first one, and then I'll give you time to do the next two. So if we start off with 285 degrees, I find it easier to draw myself a little sketch so I can picture where it is. 285 degrees would put me down here, because this is 270, and this is 360. So what they're asking is basically what they're saying, give me a positive angle within the first 360 and a negative angle. So the negative angle would be going this way. So how would I find that negative angle?
You could go 360 minus 285, and then it'd just be negative.
Okay. Or if I went 285 minus 360, would it already take care of the negative for me? Okay, so what's 285 minus 360? What'd you get, Jessica?
Negative 75 degrees.
So that's the negative angle. And then my expression that I could use to represent all angles is I start at 285 degrees, and then I add multiples of 360 degrees. And again, n has to be an integer. And it's important to put that in there, because otherwise the assumption that could be made is that n could be any number, and then that's not going to work anymore, because it could be a fraction. Okay, so I'll give you time to do B and C. Okay, so negative 13 degrees. How did you approach that one? Did anybody sketch it? Okay. So if I sketch it, what quadrant am I in, Rachel?
4.
Quadrant 4. Okay, so there's my negative 13. So then how would I determine the positive angle going this way?
Okay.
360 minus 13.
Okay. So that gives me 347 degrees. So then part 2 says write an expression involving the principal angle. Which of these two angles is the principal one? The 347 degree is the principal angle. And then to that I add my multiples of 360. Again, n being an integer. Okay? What can you tell me about C?
Has to go around more than once.
Goes right around once, and then where does it stop? What quadrant?
Quadrant 1.
Quadrant 1, okay. So how do I find out what this angle is from the x-axis to the terminal arm?
Well, it should be 35 degrees.
And how'd you get 35?
395 minus 360.
Okay. And then we also have to determine an angle the negative way, because it says within the domain of positive 360 and negative 360. So this part in here is 35 degrees. What would that part here be? How would I find that negative one?
35 minus 360.
Which would give me
Negative 325 degrees.
okay. And then the last part, an expression involving the principal angle. So which one's the principal angle?
35 degrees.
And then I'm going to represent all angles by adding multiples of 360. Okay. I'm going to finish the section off and then I'll give you the questions all at the end instead of piecing it together. Okay. Reference angles. So a principal angle is between 0 and 360 degrees. A reference angle is between 0 and 90 degrees. It is the angle I get when I take the terminal arm, no matter where it is, and I bring it to the x-axis. So if the terminal arm is in the second quadrant, this becomes my reference angle. If my terminal arm was down here, my reference angle would be here. It's going from the terminal arm to the x-axis. So in this diagram here, I have that the terminal arm is a rotation angle of 120 degrees. That's the rotation that it gets. The reference angle is 60 degrees. That's this part in here. What can you tell me about the two numbers?
Add up to 100.
They add up to 180 when I'm looking at these two quadrants. They don't always do that, so we're going to look at, try to develop a pattern is what we're going to try to do. So in each case, sketch the rotation angle and then state the reference angle. So 243 degrees would put me in which quadrant?
Third.
Pardon?
The third.
Quadrant 3. So this is my 243 degree angle. My reference angle is the angle from the terminal arm to the x-axis. So it's the one that I'm drawing in red. How do I find the measurement of that angle?
243 minus 100.
Okay. And what do I get? So the reference angle is 63 degrees. The concept of a reference angle becomes very important as we progress through the chapter. So if this is confusing, stop me and I'll keep going through it. But you have to be able to determine what the reference angle is to a rotational angle. Okay, so with that said, I'm going to give you a couple of minutes and see if you can do B and C on your own. Because I think you can. So 337 degrees puts me in which quadrant?
4.
Quadrant 4. So there's my 337 degree rotation. Then my reference angle is this piece that goes up to the do I find out that angle?
360 minus 337.
And what do I get?
23 degrees.
So my reference angle is 23 degrees. Again, always double checking that. Reference angle has to be between 0 and 90. Okay? And in the last one, where's 70 degrees?
First quadrant.
First quadrant. So there's my rotational angle. There's my 70 degrees. My reference angle is the angle between the terminal arm and the x-axis. So what's my rotational, or what's my reference angle?
70.
70 degrees. Okay? So then down here is a diagram that describes the relationship between the reference angle and the rotational angle. In the first quadrant, they're the exact same. In the second quadrant, I can figure out 180 degrees minus the reference angle equals the rotation, or 180 degrees minus the rotation equals the reference. It depends what you're given. And that's what we did in the first question. The second question, we were down here. So we can figure out the reference angle by taking the rotational angle and subtracting 180 degrees. That's what we did in the second. That's what we did right here. You took the rotational angle and subtracted 180 degrees. We'll fix that after. Right there.
No, shouldn't it be down? Oh, no, no.
It should be down. What happened to all of my... There we go. So the reference angle is equal to the rotational angle minus 180 degrees. Or the rotational angle is 180 plus the reference angle. It depends which one you're given, right? And then in the last quadrant, we found the reference angle by going 360 minus the rotational angle. If you have the reference angle, it would be 360 minus the reference angle. Okay, so we just have a couple more examples and then we are done. So on the following page, it says state the reference angle for each of the following rotational angles in standard position. Again, I would highly recommend sketching these just so that you get a visual. So if I'm at 195 degrees, which quadrant would I be in? Quadrant 3. So how do I find the reference angle when I'm in quadrant 3?
One.
195 minus 180? That's what I heard you say. And that's where the diagram can help, because instead of having to memorize what was on the last page, if I can see where my markers are, my 0, my 90, my 180, 270, I can then see how I would subtract the two. Okay, 258 degrees negative 258. What quadrant would that put me in? Quadrant 2. Because this would be negative 180, and negative 270 would be up here. So there's my negative 258. And I want to know what this portion is here. So how would I figure that out?
Subtract 100.
Okay. Would I make it a positive 258 or a negative 258 when I subtract the 180? Okay.
That's what I did.
And what did you get?
78 degrees.
And does that meet the conditions of a reference angle? Yes. It's positive, and it's between 0 and 90 degrees. Okay, the last one. Negative 810 degrees. First of all, what direction is my rotation going in? Clockwise. How many times is it going clockwise around?
Twice and then a little bit.
So 2 rotations is how many degrees?
720.
So if I add 720 to this negative 180, what would I get?
Negative 90.
So then that puts me right there. So then my reference angle is the measurement from the terminal arm to the x-axis. How many degrees is that? 90 degrees. Okay. It says determine 4 angles between 0 and 360 degrees that have the same reference angle as a rotational angle of negative 128 degrees. So the first thing that we should do is what?
We sketch negative 128 degrees.
Okay, let's sketch negative 128 degrees. What quadrant would I be in?
3.
Quadrant 3. Okay. So then my reference angle is going to be this piece right here. So how do I calculate my reference angle? How did you do it, Evan?
You go 180 minus 128.
Okay, and what did you get?
52 degrees.
So that's my reference angle. So what I'm asking for is 4 rotational angles that would have the same reference angle. So what that means is let's start off with a reference angle at 52 degrees in the first quadrant. If my reference angle is 52 degrees in the first quadrant, what's my rotation? 52. So my angles would be 52 degrees. Then if I draw a 52 degree reference angle in the second quadrant, how do I find out what the rotation would be?
And 80 minus 52.
Which gives me
128.
okay. And then in the third quadrant, I draw my reference angle of 52 degrees. So my rotation would be the part that I drew in green. So how would I find out that rotational angle?
180 plus 52.
Good. Which gives me,
234.
and then I draw my final reference angle of 52 degrees. And I want the rotation. And how would I find the rotation?
360 minus 52.
And what would that give me?
301.
So all 4 of those angles have the same reference angle as I go through my rotation. So the questions for you, 1A and C, 3B and C, 4A and B, 5A and B, and then 8 to 12.